Hey everyone, welcome to the SCM Analytics YouTube channel, your go-to place for all SCM related analytical use cases. This is Vicky here, your host for this video. Today, we will solve workforce planning problem for the ABC Cosmetic Company in one of their distribution center using linear programming. Let's get started. ABC Cosmetic Company wants to schedule the staffing for its fulfillment center. The management's objective is to schedule the work times of the DC workers to minimize the cost of providing a level of service specified by the management. Finding the minimum requirement of service is a problem of its own. It often requires forecasting and analyzing the queues in the fulfillment center to figure out the optimal value. We will discuss these set of problems in a later video. There are two types of DC workers, full-time and part-time. There are a total of 4 shifts, and we have been given the minimum number of workers required per shift in the center. For the 8 to 12 pm shift, we need a minimum of 6 workers. For the 12 to 4 pm shift, we need a minimum of 8 workers. For the 4 to 8 pm shift, we need a minimum of 12 workers. And for the 8 pm to midnight shift, we need a minimum of 6 workers. And for each shift, we have been told the number of full-time workers has to be greater than or equal to twice the number of part-time workers. This is often said as a criteria because the part-time workers are paired with the full-time workers to ensure the products are shipped following all the due diligence, as the full-time workers are trained more extensively. Full-time workers work for 8 consecutive hours, that is 8 to 4 pm, noon to 8 pm, 4 pm to midnight. Whereas the part-time workers can work only in the 4-hour shift that ranges from 8 to noon, noon to 4 pm, 4 pm to 8 pm, and 8 pm to midnight. The full-time workers are paid 14 euros per hour, whereas the part-time workers are paid only 12 euros per hour. This is a typical example of cost-benefit trade-off problem where we are given a minimum number of workers and we need to optimize for minimum cost. Let's look at the spreadsheet model to construct and solve this math model. First, let's calculate some fields for the cost per shift variable. We know that the full-time workers work for 8 hours and are paid 14 euros per hour, which gives us a grand total of 112 euros for an 8-hour shift, which is the salary or the pay that we need to give for the full-time workers. For the part-time workers, we know they work only for 4 hours and are paid 12 euros per hour, which makes their pay 48 euros per shift that they work in. Here, we are interested in figuring out the workers per shift, which is the decision variables, which is marked in yellow. The objective function is calculated using the sum product of workers per shift and the cost per shift. We need to minimize this objective. We then calculate the total number of workers per shift by adding 1 in the shift where the full-time and part-time workers can work. We know that for each full-time workers in any one of the shift, in the vertical shift between 8 to 4, is having 1 in the first 2 consecutive entries of the 6th and 7th row, which is 8 to noon and noon to 12. With this, we can calculate the full-time and part-time workers working for the shift mentioned by the management. We also calculate the other criteria, which is only by considering the full-time workers who would work for the shift. This is often done by only multiplying the workers per shift into the shift covers in the fulfillment center. Here we also mention the other criteria, which is the full-time workers have to be greater than or equal to twice the part-time workers working in the fulfillment center. With this, we have created the necessary fields for the solver. In the solver, we mention the objective as the total cost, which we need to minimize by changing the workers per shift variables and the 2 constraints mentioned here. That is the minimum number of workers required per shift and the other criteria of full-time workers, which are mentioned in the constraints. Let's solve this mathematical model. We also ensure the variables are not negative, and we use the simplex linear programming method. On solving the model, we are given the following outputs. We need 4 workers in the first 8 to 4 p.m. shift for full time, 2 workers in the second shift for full time, and 6 workers in the third time. Similarly, we don't require any workers for the last shift in part time, and 2, 2, and 4 for the first 3 shifts in the fulfillment center. With this, we minimize the total cost as 1728 euros. This is the cost required for the fulfillment center to operate and meet its minimum service levels. The contents presented in this video are available in the description below. Thank you for watching this video. I hope this video was useful. Please subscribe to the channel and click on the bell icon for updates on future videos. Until then, take care, bye, and happy learning.